I've written the product and quotient rule on the side of the board here. There are definitely things that get better with more usage. The more practice you get with them, the easier it is to remember. I've written the generic definitions here where they're in terms of one function f of x times another function g of x. I prefer a way of remembering them that I used to teach when I taught in high school, which was if you have first times second, the derivative is first times derivative of second plus second times derivative of first. When we talk about the quotient rule, again, it's listed here in generic math terms. I like to teach it as high over low. So high is the top function, low is the bottom function, and the way I remember it is low d high minus high d low over low low. So you might hear me refer to those things just because I'm used to kind of saying as I go along as a memory device for me. I don't mind you having these rules in front of you on a note card when you take the test, so you will have whatever way you best want to use it, but again, just to try and remember it as I was going to write these out for you, I definitely did it as first times derivative of second plus second times derivative of the first, and then low d high minus high d low over low low. For this first product rule, we need to rewrite the first function, 5x minus 2, times the derivative of the second function. The derivative of 3x plus 4 is just 3. The constant goes to 0, something in front of x just becomes that. To that, we need to add the second, 3x plus 4, times the derivative of the first, in this case just 5 for this parentheses. When I multiply this out, 3 times 5x gives me 15x, 3 times negative 2 gives me negative 6, 5 times 3x gives me another 15x, 5 times 4 gives me 20. So my final answer is this 15x plus this 15x for a total of 30x, this negative 6 and this positive 20 for plus 14, for a final answer of 30x plus 14. When I go to do part B, first x to the fifth times derivative of second, derivative of cosine is negative sine x, plus second cosine x times derivative of first, derivative of x to the fifth is 5x to the fourth. There's no like terms here, so all I can do is simplify by saying this first term is negative x to the fifth sine x, while the second term is positive 5x to the fourth cosine x. When I go to do this h of x, it's probably better to remember that this root of x is really x to the power of 1/2. When I go to do the derivative, it's going to be first x to the 1/2 times derivative of second, derivative of x plus 8 is just 1, plus second, which is x plus 8, times derivative of first. I'm going to cheat a little here and use what we did in a previous classwork, which found the 1/2 went out front, it became to the negative 1/2, which took it to the bottom. So in the end, we got 1 over 2 the root of x when we did that. I need to multiply this out a little further. This is just the root of x, because anything times itself, anything times 1 is itself. Here, the x plus 8 goes to the top, so I get plus x plus 8 on top, the root of 2 the root of x on bottom. I could find a common denominator, try and combine those further, but really leaving that here is mathematically correct. We're going to use the quotient rule when we find these derivatives. So again, I do it as h prime of x equals low d high. Low is x plus 10. D high is the derivative of x, which is just 1, minus high d low. High is this x. D low is the derivative of this whole bottom. The derivative of x plus 10 is just 1. All over low low. So it's just going to be x plus 10 quantity squared. I can clean up the top a little. This becomes just x plus 10. This becomes minus x. So this minus x and this positive x reduce. They just leave me with, on top, 10. Still over x plus 10 quantity squared. Now that I have this answer, I'm moving on to this one. H prime of x, in this case, is low d high. So x to the third is low. D high is the derivative of sine x, which is just cosine x, minus high d low. High is sine x. D low is the derivative of x cubed, which is 3x squared. All over low low, which is x to the third power squared. On top, this becomes x to the third cosine x minus 3x squared sine x, all over third to the second power. I multiply and just becomes x to the sixth. I definitely could clean this up a little more by reducing everything by x to the second. If I did that, my answer would become x cosine x minus 3 sine x all over x to the fourth. All right. For this h of x, when I go to find h prime of x, I do low cosine x, d high, the derivative of x squared plus x is 2x plus 1, minus high x squared plus x. D low, the derivative of negative cosine, or derivative cosine x is negative sine x, all over low low, which is really cosine x squared. I'm not going to have any like terms here, but I still am going to multiply things out to get all the different terms. The first term is 2x times cosine x, 2x cosine x. The next term is 1 times cosine x, so plus cosine x. The next term is negative times a negative, which makes a positive, x squared sine x, plus x squared sine x. The next term is a negative times a negative, which makes it a positive, sine x times x, which is positive x sine x. It's still all over cosine x squared. When we find a second derivative, basically that just means we find the derivative the regular way by the derivative process. Then once we found it, we take a derivative of that answer to find the second derivative. So when we go to find the first derivative for part A here, we'll be using the product rule. First, x to the fifth times derivative of the second, negative sine x, plus second cosine x times derivative of the first, x to the fifth becomes 5x to the fourth. We can rewrite it as negative x to the fifth sine x plus 5x to the fourth cosine x before taking a second derivative. When we go to take the second derivative, h double prime of x, first thing we encounter is this x to the, or negative x to the fifth sine x, which is itself a product rule. It tells me to do first negative x to the fifth times derivative of the second, cosine x, plus second sine x times derivative of the first, negative 5x to the fourth. Then I need to deal with this 5x to the fourth cosine x, which also creates a product rule. So I'll be doing first, which is 5x to the fourth, times derivative of the second, which is negative sine x, plus second, which is cosine x, times derivative of the first, which is 4 times 5 gives me 20x to the third. Hopefully you can see that we have two terms that are like terms in the middle here. This sine x times negative 5x to the fourth and this 5x to the fourth times negative sine x give me a total of 10x to the fourth sine x negative. So when I'm rewriting this whole thing, the first term is negative x to the fifth cosine x. The second term is the combination of these two, which becomes negative 10x to the fourth sine x. And my final term comes from this, which is plus 20x to the third cosine x. When I go to do part B here, this is again one that we did above and found the first derivative of, but I'm going to go ahead and work through it and show how we found that first derivative. So h prime of x is low x plus 10 d high 1 minus high x d low 1 all over low x plus 10 squared. When I simplified this negative x and this positive x went away and just left me with 10 over x plus 10 times x plus 10, which I'm going to call x squared plus 20x plus 100. If I now go to take a second derivative, my second derivative, h double prime of x, becomes low d high. So low is x squared plus 20x plus 100 times d high. Well, the top is a constant, so its derivative is 0. Minus high, which is 10, times the derivative of the bottom. If I take the derivative of this version, it becomes 2x plus 20. All divided by low. Well, it was already x plus 10 squared. If I square it again, it becomes x plus 10 to the power of 4. When I multiply out the top, 0 times anything is 0, so I really just get these terms. Negative 10 times 2x gives me negative 20x. Negative 10 times positive 20 gives me negative 200. On bottom, x plus 10 to the fourth can just stay like that. X plus 10 to the power of 4. When I go to find the second derivative of 12 root x, I'm going to start by reassigning this as 12x to the 1/2. When I then take the derivative h prime of x, that 12 stays there. I get on bottom 2 root x. Again, this came from it becoming negative 1/2 that went there, and from the 1/2 coming out front to create that 2. So this really, when I reduce this 2 and this 12, becomes 6 over the root of x. I can write that as 6x to the negative 1/2. It's really probably better if I leave it in terms of negative exponents and fractional exponents until I get to the final derivative that I'm taking. So here when I do h double prime of x, I have 6x to the negative 1/2. The negative 1/2 comes out front to be multiplied by the 6. The x power used to be negative 1/2. I'm now subtracting another 1, or negative 2 over 2. Negative 1/2 times 6 gives me negative 3. The power on the x is negative 1 minus 2, which is negative 3 over 2. That means this negative 3 stays on top of the fraction. On bottom, it comes down as x to the 3/2 positive, which I then rewrite as root number on bottom, 2, which is understood, power on top, which is x to the 3rd. So the second derivative of 12 root x is negative 3 over the root of x cubed.